Good morning, students. Welcome to online classes. In previous session, I have discussed 90 degree minus theta, 90 plus theta, 180 minus theta in terms of cos theta. So, in previous classes, we have discussed how to formulate the formula using SGC. So, today we will learn addition and subtraction formula. So, let's start. So, first we have to discuss addition and subtraction. Okay. So first is sin a plus b. So sin a plus b is equal to sin a into cos b plus cos a into sin b. So this is the addition formula in terms of sin. So sin a plus b is equal to sin a into cos b plus cos a into sin b. Okay. So how to learn the formula of sin a plus b? So it is a formula in an alternate form in sin and cos. If the first term is sin a into cos b, the second term is the alternate of this. So sin a plus b is equal to sin a into cos b plus cos a into sin b. Same to the sin a minus b, that is equal to formula of sin a plus b and sin a minus b equal but changes in the sign. So here we can write sin a into cos b minus cos a into sin. So that is the formula of sin a minus b. Okay. So next we proceed to cos a plus b, and cos a plus b is equal to cos a into cos b minus sin a into sin b. As you see in sin formula, here we have plus or addition, then formula also same sign. But in case of cos, if we formula of addition, then the result in this alternate form. That means if it is in addition, then it can be written as in subtraction. Okay. And in case of cos, the both first term of the trigonometry ratio the same value, that is cos a into cos b minus sin a into sin b. So similar to cos a minus b, that is equal to cos a into cos b, as the sign is negative, so we can write here positive. So cos a minus b is equal to cos a into cos b plus sin a into sin b. So if you learn the addition formula, then you can also learn the cos a minus b. Okay. So next proceed to tan a plus b, that is equal to tan a plus tan b by 1 minus tan a into tan b. Okay. Tan a into tan b. So in case of addition, so first the numerator is addition and the denominator is the negative term. Okay. So tan a plus b is equal to tan a plus tan b by 1 minus tan a into tan b. So the next one is, that is tan a minus b, similar to tan a plus b. That means this changes the sign of this expression, that is tan a minus tan b by 1 plus tan a into tan b. So these are the addition and subtraction formula in terms of tan. Okay. So next we proceed to cot a plus b. But these first three are the primary formula of the T ratio, sin, cos and tan. So let's do now cot a plus b, and the cot a plus b is equal to cot a into cot b minus 1 by cot a plus cot b. Similarly, in case of cot a minus b, that is equal to cot a into cot b plus 1 by the exceptional formula. Here we can write cot B minus cot A. So cot A minus B is equal to cot A into cot B plus 1 by cot B minus cot A. So these are the addition and subtraction formula in terms of cot. Okay, so these are the addition and subtraction formula of T ratio. Okay, so why we learn this formula? Why to apply this formula? So let's take an example to apply that this formula is. So here take an example, that is find the value of suppose sine 75 degree cos 15 degree. Okay, so here we have to calculate or evaluate the value of sine 75 degree and cos 15 degree, but in our standard angles table 75 and 15 degree are not available. So according to standard angle tables, we have to evaluate sine 75 degree and cos 15 degree. So how to calculate? First we have to find sine 75 degree. So 75 can be expressed in addition or subtraction form, but you can write 75 in terms of, you can write in 45 plus 30, because these two values are these values that involves in standard angle tables. Okay, 45 and 30. You can write 75 into 60 plus 15 degree, but 60 degree is involved in table, but 15 degree is not available in this table. So we cannot write this form, but we can express as 45 plus 30, because 45 and 30 both are involved or included in the standard angle table. So in terms of 75, we can be expressed in addition form, that is 45 degree plus 30 degree. So 45 degree plus 30 degree means we can apply here sine A plus B. So this is the formula that we apply this expression. Okay, so here A is 45 degree and B is 30 degree. So we apply sine A plus B. So formula of sine A plus B, according to formula of sine A plus B, then we can write sine 45 degree into cos 30 degree plus cos 45 degree into sine 30 degree. Okay, so we apply this formula to evaluate cos sine 75 degree. Okay, now we can put the values of this T ratio according to standard angle table. In previous session, we have discussed how to evaluate this value. Okay, so the value of sine 45 degree is 1 by root 2 into cos 30 is, as you know, root 3 by 2 plus cos 45 is same to sine 45, that is 1 by root 2, and sine 30 is 1 by 2. So first multiply, then addition, that is root 3 by 2 root 2 plus 1 by 2 root 2. So the final answer is, we take an LCM 2 root 2, that is root 3 plus 1 by 2 root 2. So this is the value of sine 75 degree in a irrational form or irrational number, that is sine 75 degree is equal to root 3 plus 1 by 2 root 2. Similarly, you can expand or you can evaluate cos 15 degree. Let's start to evaluate cos 15 degree. So the values of cos 15 degree. So first we have to write, what we write in terms of 15 degree. But here we can write 15 degree as addition or subtraction. But we cannot write in addition form, because if we write 15 degree in terms of 10 degree plus 5 degree, but these values are not in the standard angle. Okay, so we cannot write 15 degree in addition form, but we can write 15 degree in terms of 45 degree minus 30 degree, because 45 degree minus 30 is equal to 15. So in places of 15 degree we can write 45 minus 30, or we can write 60 minus 45. We can write this form or this form, because both values are in the standard angle tables. So here we can write cos 15 degree is equal to cos 45 minus 30. So that is equal to, now here we can apply this formula, that here the values is cos, so we apply this formula cos A minus B. So formula of cos A minus B is equal to cos A into cos B. So we can write cos 45 degree into cos 30 degree plus sin 45 degree into sin 30. So now we put the values of these T ratios, that is cos 45 degree, that is equal to 1 by root 2 into cos 30 is equal to root 3 by 2, sin 45 is equal to 1 by root 2 into sin 30 is equal to 1 by 2. So now can be write as root 3 by 2 plus 1 by 2 root, and the final answer is root 3 plus 1 by 2 root 2. So here you can see sin 70, the values of sin 75 is same to the cos 15, because both are the same. So here we can evaluate or calculate sin 75 degree is equal to root 3 plus 1 by root 2, and cos 15 is also root 3 plus 1 by 2 root 2. Similarly, can be expand, or we can evaluate cot 105 degree, sin 15 degree, cos 75 degree. So we can express these values in terms of given decimal part. Okay, so this is a homework to evaluate, to find the value of cot 105 degree, sin 15 degree, cos 75 degree, tan 75 degree, cot 15 degree. So this is the question to evaluate these values. It is your homework to evaluate some bits here. Cot 105, how to break them 105, you can write in places of 105 degrees equal to 60 plus 45 degree. Okay, 60 plus 45 degree. So here we can apply the formula cot A plus B. So if you find the value of cot 105, then you can use the formula cot A plus B. Similarly, can be evaluate this all T ratio. So this is the procedure to evaluate this value. Okay. Now take another examples to how to apply addition and subtraction formula to a problems. Okay. Now we take another examples that prove that sin A into cos B minus C plus sin into sin B minus C plus sin B into sin C minus A plus sin C into sin A minus B, that is equal to 0. So we have to prove that sin A into sin B minus C plus sin B into sin C minus A plus sin C into sin A minus B, that equal to 0. So we have to prove that. So first we take an LHS. So here the LHS is sin A into sin B minus C plus sin B into sin C minus A plus sin C into sin A minus B, that is equal to, you can put the formula according to addition and subtraction. So here we can write sin A into sin B minus C, as you see in previous chapter that sin A minus, but here sin B minus C. So you can write A in terms of B and C in terms of C, sorry, B in terms of C. So you can write sin B minus C is sin B into cos C minus cos B into sin C. Okay, plus similarly you can write sin B into, here you can apply the same formula. So that is sin C minus A, that is sin C into cos A minus cos C into sin A. Plus sin C into, the formula of sin A minus B is sin A into cos B minus cos A into sin B. So this is the formula to apply this expression. Okay, now we can multiply, because here in bracket form. So if we break the bracket, then that means we can multiply simply. So here you can write sin A into sin B into cos C minus sin A into cos B into sin C. So this is the first part to multiply. So next one is plus sin B into sin C into cos A minus sin B into cos C into sin A plus sin C into sin A into cos B minus sin C into cos A into sin B. Okay. So now check it is cancelled or not. So here sin A into sin B into cos C, and that is equal to the fourth, I think, the fourth term, sin A, sin B and cos C. So first part and the fourth term are both in opposite in sign, but value is same, so we can cancel them. Similarly, the second values, sin A into cos B into sin C, sin A into cos B into sin C, that means second and fifth are same, and the sign are the alternate, so we can cancel them. And the remaining third and sixth are also same, and the sign also opposite, so we cancel all these expressions. So the result is 0. So here you can see the RHS part is also 0. So here we can prove that LHS is equal to RHS. So these are the addition and subtraction formula that we apply in problem. Okay, now next we have to learn multiplication of product formula, and that is transformation of addition, or you can see sum and product. Transformation of sum and product. So here the first formula is, that is sin A plus B, or you can write 2 sin A into sin B, or sin A plus B plus sin A minus B. Sin A plus B plus sin A minus B. If we will apply the formula sin A plus B and sin A minus B, then we can cancel these two expressions, then we get the result 2 sin A into cos B. So the analysis part or the left part is the addition subtraction and the right part is the product. So here is the transformation of summation or subtraction into product, or we can express product into addition and subtraction. Okay, so the next one is sin A plus B minus sin A minus B. So here we can, if we apply this formula, then we get the result 2 cos A into sin B. 2 cos A into sin B. And the next one, that is the third formula, cos A plus B plus cos A minus B. Then you apply the formula cos A plus B and cos A minus B, and here to also cancel the two terms, and we get the result 2 cos A into cos B. And the fourth part of the fourth formula, and that is cos A minus B minus cos A plus B. If we write first negative and then positive, then we get the result in positive form. So here we can write 2 sin A into sin B. 2 sin A into sin B. So these are the four formula that transform of sum into product, or we can see product into addition and subtraction. So this is that is the fourth formula, or number of formula that you can transform to sum and product. Now next we learn conversion of a sum, conversion of sum or difference into product. And this is the alternate form of this above four formula, that you can write. The first formula is sin C plus sin D. That means if we put in terms of A plus B, that is C, and in terms of A minus B, that is D, so sin C plus sin D, you can write that 2 sin C plus D by 2 into cos C minus D by 2. So this is the formula that you can write in the single terms, that is in places of A plus B, then you can write C, and in place of A minus B, that is D. So you can write sin C plus sin D, that is equal to 2 sin C plus D by 2 into cos C minus D by 2. And the next one is sin C minus sin D, and that is also 2 cos C plus D by 2 into sin C minus D by 2. You can see the formula of first and second. In cases of A, that is, you can write C plus D by 2, and B, C minus D by 2. And the third one is, you can write cos C plus cos D. So the formula of cos C plus cos D, that is 2 cos C plus D by 2 into cos C minus D by 2. And the fourth formula, that is cos, you can write D minus C, because here we take A minus B as D and A plus B as C. So here we can write cos d minus c, or we can write cos c minus cos d. So if we write cos c minus cos d, that we can write 2 sin c plus d by 2 into sin d minus c by 2, because here we changes the sign terms. Or we can write minus of 2 sin c plus d by 2 into sin c minus d by 2. So this is the transformation of above 4 formula. So now why we learn this formula and how to apply this formula in a problem. So now take an examples. We apply this formula. So suppose in examples prove that sin 2a plus sin 5a minus sin a by sin 2a plus sin 5a minus sin a by cos 2a plus cos 5a plus cos a, that is equal to tan 2a. So here cos 5. Okay. So here we have to prove this expression is equal to tan 2a. So let's first we take an LHS. So here LHS is sin 2a plus sin 5a minus sin a by cos 2a plus cos 5a plus cos a. So first we write the LHS part. Now which formula we apply this expression? So here you can see in numerator that there are 3 terms here. First we can, if we take first 2 terms, then we can apply sin c plus sin d. Okay, but if we have take last 2 terms, that means second and third, then we can apply the formula sin c minus sin d. So if you take first 2, because 2a and 5a both, if we add them, then it is not odd. But if we take last 2 terms, if we add them, then we get the values 6a, that is an even. So because the formula is d by 2 c plus d by 2, so we take, if we add them, it is now even. So this part we can take. Okay, so here we can take the last 2 terms. Similarly, in denominator we can take also 5a and m. That means we take an odd part. Okay, so here sin 2a plus, now we apply the formula sin c minus sin d, that is the second formula, sin c minus sin d, you see. So here according to formula 2 cos c plus d by 2, that means 5a minus a by 2. So 5a plus a by 2, 5a plus a by 2, that means 6a by 2. That is, you can write directly 3a. So 2 cos c plus by 2, then sin c minus 2 d by 2. That means sin c minus d, that means we will subtract. If we subtract, then we get 4a by 2, that is 2a. So sin 2a by, and we can evaluate, we can be express same to the numerator. That means here you can write cos 2a plus, but here we apply the formula of cos c plus cos d, because here the sign is positive. So here we can apply cos c plus cos d, and according to cos c plus cos d, that is 2 cos 2 cos c plus d by 2, that means we will add them, that is 6a by 2, that is 3a, into cos c minus d by 2, cos c minus, that is 4a by 2, that is 2a. So we can write directly. Now you can see here we take commons here, that is sin 2a. So if we take sin 2a in numerator, then we get 1 plus 2 cos 3a. And in denominator, we take common cos 2a, then we get 1 plus 2 cos 3a. So here you can see, or you can cancel these same values, that is 1 plus 2 cos 3a, 1 plus 2 cos 3. So here you can write sin 2a by cos 2a, that is n 2a, and that is the same values of the RHS. So we have proved the expression LHS into RHS. So these are the formula. To first we have to learn them and how to apply this formula in problems. Okay, so have a nice day. Thank you.